All right, welcome back, everyone. Today we are talking about namespaces. So, before we get into what a namespace actually is, I want to remind you of two things you already know because namespaces are really just these two ideas colliding with each other and creating something new. A quick refresher, you remember that a local variable only lives inside a function block where you declared it. Once you leave that block, it's gone. Nobody outside can see it or touch it. A global variable, on the other hand, is different. You declare it outside of any function, and now it's visible to the entire program. That sounds convenient, and sometimes it actually is, but convenience has a cost here. The more global variable you have, the easier it is for two of them to accidentally get the same name. And when that happens, you've got a clash. So keep this picture in your head. One big shared space where names can collide. Then quick refresher part 2. We have compilation process and header files and what's going on there. So when you write include custom header.h or something like that, the preprocessor doesn't do anything clever. It literally copies whatever the text the header file had and pastes it directly into your source file. Before this happens before the compiler even starts doing anything. That's it. Simply, it does just that. No magic, nothing else. So, let's see how that happens. I think we could take a look at it and get some idea. Okay, here we go. So, okay, let's create a folder first. This is our example one. Let's navigate to that folder. Now, let's create a simple header file. Let's say greetings, greeting.h, and then it has maybe a simple function like void say hello. And yeah, it could standard C out hello world, simply just that. Now let's create a simple main.cpp where we will include IO stream, and then we will include our greeting.h, then a simple main function that says say hello and return 0. So here, instead of directly compiling this normally, I'm going to ask the compiler to stop before it actually compiles. And it will happen right after pre-processing. So we can see what it actually is looking at. So in the terminal, let's type g++ dash cat e main.cpp, and then we will output the file as main pre, let's say. There you go. A main pre.cpp got generated. Here we have a huge file. This got pre-processed, and here right at the end you will see your program main say hello return 0, but right before it you will see that we have our greeting.h directly pasted right before our main program. So here this function got pasted right before this one. Let's get back to our slide. Okay, let's set that aside for a second and let's talk about something else that has nothing to do with namespaces or anything at all. Let's imagine you are planning a big family holiday. You've got two people helping you out. One person handles accommodation and they hand you back a file called schedule.txt, and the other person handles activities and they also send you back a file called schedule.txt. Same name, completely different content, completely different source, and everything. Now, you, as a planner, you want to dump both of these files into a same place so that you can sort things out or you can combine things together and create a combined plan for everyone else. So what do? You drag both files in and your operating system stops you right there. A file named schedule.txt already exists. Do you want to replace it or not? This is a naming collision. Two things, same name, one location. The system has no way to tell them apart. If you click replace, you just destroyed one of them. You genuinely cannot have both files at the same place, in the same folder, with the same name. It's not that the OS is being difficult, it just has no concept of these are actually different things that happen to share a name. It doesn't have a concept of that. So, you could say that's exactly the Spider-Man pointing at Spider-Man problem. Two identical labels and nobody can tell who's who. So, how do you actually solve that folder problem in real life? Subfolders, right? You would put one schedule.txt inside an accommodation folder and another one in an activities folder. Same file name, no collision, everything stays same because they are not really in the same place anymore. A namespace in C++ does exactly that. Here you have two namespaces named accommodation and activities, but you have two classes both named schedule. So they are living happily side by side because they are in different subfolders. Here the subfolders are actually different namespaces. Okay, let's head to the next one. So here's why this matters for real software, not just some holiday planning. There's only so many good and sensible names to go around, like print value, connect, or print, something like that. In a small program, that's not an issue, but once your software pulls in multiple libraries or you are working with a big team, the odds of two independent pieces of code having the same name gets way up. So, for an example, let's say there's two different libraries that you are using. They both define a same function named print value. Or there is a third-party class library that you brought in. It happens to define a class with the exact same name that you already wrote yourself. And here's the annoying part. It doesn't matter how it happened. Either way, your program will not compile. The compiler sees two things claiming the same name and just refuses to guess which one you meant. So the solution to this problem is really simple in C++. This is the exact thing that we talked about, the subfolder trick. It's namespaces. So the whole point of a namespace is to give you a hierarchical naming system that is built right into the language. So it lets you divide your software into logical parts, and as a side effect, it prevents those different parts from stepping on each other's names. So let's see it actually resolve a real conflict, shall we? Let's clean up our workspace here for a little bit. And let's say example 2. Here we have, let's include IOStream. Then for the sake of simplicity, we will use the namespace std like this here, so that we don't need to type out standard again and again. We will cover this using clause in just a little bit later. So here, let's define a namespace first. So namespace accommodation, let's go ahead with our example. So here we will define a class named schedule, just like in our example. And here, let's go for a public function, which is, void print. And then let's go with this one, accommodation schedule. Here we missed a semicolon. Now let's define another namespace named activities, just like our example. And yeah, it looks all right. We have a class schedule here, which has a same function named print that prints activity schedule. So let's go ahead and use those namespaces. So here in main, we have this. As you can see, it generated the necessary bits for us. So let's go ahead with that. We have our accommodation namespace and activities namespace. We will use the class of accommodation namespace, and we will use it with this name. Let's say we will rename it as accommodation schedule. So whenever I need to access the schedule class from accommodation, I will just use accommodation schedule like this, just like how we defined, and we will access the print function and call it right here. So now if we run this code, see, it runs without any conflicts at all. Let's get back to our slide. So now that double colon you just saw has a name. It's the scope resolution operator. Sometimes it's called the visibility focus operator. Members defined inside a namespace are only visible inside that namespace by default. To reach in from the outside, you have to use this double colon operator or visibility focus operator. And it's not called double colon operator, it's just For the sake of simplicity, I'm using this naming for now, but actually it's visibility focus operator. And here you have to name both the namespace and the thing inside it. So here, let's say database, connect, library, print, that kind of pattern. And yes, it's a bit more typing, but that's honestly a feature, not a bug. So when you need database connect, you instantly know where the function lives. There's no guessing and there's no searching or anything like that. So namespaces meaningfully cut down your risk of name conflicts because each module's names live in their own scope now. The structure of your software becomes visible right there in the syntax because of that double colon. And despite putting up this wall between modules, code inside the same namespace can still see and use each other freely. The wall's only there for outsiders, and that's just it. So let's see that last point. Two libraries using the common names without any conflict at all. Let's just check that out quickly. So here, let's open another file right under lecture 9, which is example 3. So here, let's include IOStream like that. And let's say we have namespace database where we have a function connecting to the database. Yeah, it works. Then also let's say we had, I think, library, namespace library. It has another function, let's say print, and then it will print library schedule. So let's use both of them. So database connect, library print, just like that. Let's save it and run it. Yeah, connecting to the database, library schedule. We will use a namespace like that, nothing fancy. Okay, so let's head into the next one, which is finally the standard namespace. Now here's one namespace you have already got used to with, the STD, without necessarily knowing that what it actually means. The C++ standard defines this namespace for basically everything the language and its standard library provide. Standard printf, standard cout, all of it. Every modern compiler uses it. One important rule is that this std is reserved. You don't get to add your own stuff into it. It's the standard library space and not yours. So just stay away from it. Let's head back to the next one. So when this namespace got introduced, the C++ committee had an old problem to solve. They didn't want to break every existing C++ program that already used the old style headers. So their solution was to drop the .h of the standard library and the library headers entirely. So include iostream.h became just include iostream with no extension. And because C++ is built on top of C, you still can pull in the old C standard libraries too, but those get a slightly different name and slightly different treatment. So drop the .h and stick a lowercase c in front of that. So the old C string library, which used to be string.h, became C string in C++. So let's see what the using means. As you can see, I have already told you, we used using, then namespace, then standard. Because of the statement, we didn't have to write standard cout or standard endline everywhere else. It's exactly doing that. So typing a standard in front of every single cout and every single endline, every string gets really tiresome really fast. And I really won't pretend otherwise, because it can get sometimes really tiresome. So that's what using is for. If you are going to reuse a name from some namespace over and over again in the same block of code, this using clause lets you drop the double colon qualifier, and it lets you use the namespace without mentioning the name again and again. There are two flavors here. A normal using statement pulls in just one specific name. Using namespace pulls in everything from the namespace at once. So whichever is the convenient one, you will use it like that, but it's also how you accidentally reintroduce the exact name collisions we have spent this entire lecture avoiding. So use it with a bit of care. So let's see the difference in an example. So let's go for example 4.cpp. Let's include iostream. I don't know why it's doing that. Okay, so let's say using standard cout, and then using standard endline, and in the main function we will use it like this. Here I only pulled out cout and endline by name, and nothing else from standard got dragged in. If I would instead have had written like using namespace standard, it would have pulled in the entire namespace along with it, and there I wouldn't have to use these again and again. But there are some issues with that. There might be some name conflicts with other keywords from namespace. So that's why whenever we want to avoid that, we can just drop this line and use it like this, so that and run smoothly. So there's a couple of practical habits around where you actually put using. First, put your using statements after all your include statements, not scattered in between them, and not scattered in between your code, nothing like that. Just use it right after the include statements. Then secondly, never put a using statement inside a header file. If you do, you force that choice into every single file that includes your header. Whether they want it or not, it's there and you cannot change it. If you have to change it, you will have to redeclare those statements again outside the header file. So we want to avoid the name collision risk that we are actually talking about. And if you put the using statement right inside a header, it will pull the namespace every time you call the header. So let's look at what that actually looks like and how it is laid out in real life, because the order matters for readability. So here let's open another example, example 5. Let's include, let's say, date.h. Then let's include swbus.h. Also, let's include database.h. Then let's include, I don't know, log.h. Let's say these are the files that we have in our code base, and then we include the IO stream, and then we use the namespace like this. Sorry for that. And let's say we can also use the end line like that. And then let's include vector. And let's say we use standard vector like this. Also, let's include string, and we use standard string like this. Okay. Now, when you use the date, the log, and the error namespace, just use it like this, using date for D, using log for warning like this, and using once again log error like this. My own project's headers go first, the date.h, swbus.h, and so on. So it's easy to glance at the top of the file and check that I haven't forgotten one. Then the standard library headers. So here each one immediately followed by the specific using for the names I'll actually need from it. And then right at the bottom using statements for my own modules like date D, log warning, stuff like that. It's a small thing, but trust me, 6 months from now, when you or a teammate opens this file, that order tells a story that here's what the file depends on. Here's exactly what it's borrowing from and from which place. So that's worth the extra structure, and it actually helps a lot towards the readability of the entire code base. Okay, so let's move back to the slides. Here you can see I have explained all of these in this slide so that whenever you revise everything, it stays in your head. Okay, so next one, we have the last piece for today. You can actually give a namespace an alias, a synonym. Once you do, using the alias behaves exactly like using the original name. So, why would you want to do that? Well, I have two big reasons for you. It makes it much easier to swap one module out for another later without rewriting every line that uses it, and it gives you a short, friendly name to stand in for something painfully long. So here we have an example. Walk through this with me. Depending on the prjlib in use is defined or not, str becomes an alias for either some third-party library's namespace or the plain old standard. Either way, the rest of the code says str colon colon string. So it doesn't care whether the str is pointing at std or this one. It doesn't really matter. What matters is whatever is defined here in this code base, it will use the string from that namespace exactly. That's genuinely powerful if you say. If you ever decide to swap out that fast custom string library that you have been using, and if you just change one line right here at the top, everything in your program that uses str colon colon string will keep working anyways. You are not hunting through the whole code base like where did I use the str or where did I use str, is it here or is it there? You won't have to look for anything. It will just work every time. So, I hope everything makes sense. The goal is to help you create more readable code using the namespace concept and using it to its full potential. So, happy coding. See you in the next lecture. Bye bye.